Hello. Am I audible? Yeah, cool. Okay. Cool. Just give me 1 second. Okay. My screen is visible to everyone, right? You can see computer programming written, right? The screen is visible to everyone. Okay, cool. Cool enough, right? So I think we'll start, okay, without wasting any more time. I think we should get started. And periodically after 10 to 15 minutes, I will be looking at the charts and getting back to any of your concerns, right? So I think let's get started, right? We have people and we can start, right? Just give me 1 second and we can start. Okay. Yep. So welcome everyone. Like initial hiccups hote hai kabhi kabhi, but yeah, I think now we are good to go and we can get started, right? So as I mentioned earlier also that, I will be teaching module 1 from scratch, right? So initial 1 or 2 classes might be a little theory oriented, but I think it is important for all of us, especially, the people who are from non-tech background, to get familiar with all these concepts, right? So I think we all are here to study computer programming, right? But even before I start to discuss anything about computer programming, let me first try to break this word into 2 parts and try to understand what is the actual meaning of computer programming, right? Once we can understand what is computer programming, then we will discuss about, languages and all those things, right? So if I break this, if I break this word computer programming, I can basically break it into 2 parts. Okay, one is computer and the other is program. Of the words computer and program, then maybe I will be in a better position to understand computer programming, right? So what is a computer? What is a computer? Can anybody help me? What is a computer? Is there anyone who has not come across a computer? I am pretty sure that all of us have interacted with a computer at some point of time or the other, right? Now, computer is so ubiquitous that all of us have used computers knowingly or unknowingly. Such is the widespread usage of technology today, right? So if I want to give you a very, very simple definition of what a computer is, okay, so I think most of you here would have watched the film Three Idiots, right? So the professor asked Amir Khan, what is the definition of a machine or a zip, right? So, he gave a very, very complex answer. Okay. So what the professor wanted to hear. But I won't go into the complex definition of a computer. We just want to understand what is computer in the most simplest terms as possible. In the most simple way, I have to understand, boss, what is a computer that we are dealing with? So if I tell you, boss, you know what a computer is? A computer is nothing. It is just a simple electronic device, right? A computer is an electronic device or an electrical machine, right? Whatever you call it, it's a basic machine, right? That is what a computer is at the end of the day. Now you will come and ask me, boss, what is an electrical machine? You told that, okay, a computer is an electronic device or a machine, but what is a machine? And again, without going into the very complex definition of what a machine is, I will tell you that, hey, you know what is a machine? Anything which reduces human effort. A machine is nothing which helps me to reduce human effort. Okay. Okay, so a machine will help us in our day-to-day lives, and it will help in reducing human effort. Okay, so now you will come and ask me ki, okay, I understand what a computer is. It is an electronic device or an electrical machine, and I know that yes, a machine is something that is helping to reduce human effort. But how does a computer actually reduce human effort? How does a computer help me in the first place, right? So let me give you a very simple example to help you guys understand how a computer helps in reducing human effort, right? So let's take a very simple example. Okay, if I give you, hey, can you please compute 7 plus 2 for me? I think most of you will be able to compute this mentally, and you will tell me that, hey, you know what, 7 plus 2 is 9. Okay, now if I give you another computation, what is 55 plus 8? You will again tell me mentally that, boss, 55 plus 8 is 63, right? So as long as I am giving you small numbers, I am giving you easy computations, you can compute all this stuff mentally. Up mentally, you can compute these, you can make these operations mentally, and you can give me the answer in a very short period of time, in a short span of time. But let's say now I increase the complexity of my task. I ask you, hey, can you tell me what is 9285281 plus 36485 minus 283426? I am pretty sure none of you have followed what I told, right? What is the basic idea behind me telling such numbers? I want you guys to understand that once I make my numbers large, I make the numbers very large, it will not be humanly possible for you to carry out the operations mentally and give me the answer in a short span of time. And now can you tell me what device you will use when I give you very, very complex numbers to add up or subtract or multiply? What is the tool that you will be using to simplify your job or to reduce your effort? Okay, so you will be using something known as a calculator. Aap kya karoge? You will take up a calculator, you will type in the large numbers inside the calculator, and you will get the answer. So a calculator, what is a calculator? At the end of the day, a calculator is also a computer that has helped me to reduce my effort. Okay, instead of me taking down a piece of paper and writing down these complex numbers and performing addition, okay, a calculator has made the task very simple for me. I just have to enter the numbers, enter a plus sign, and it will give me the result in a fraction of a second. So that is how it has helped me to reduce human effort. Similarly, if I give you another example, right? So let's say I have the marks of 10 students. Okay, let's say that I have the marks of 10 students, and I want to compute the average of the marks of these 10 students. My job is, hey, can you please compute the average marks of these 10 students? So what you will do, you will add up the marks of these 10 students, and you will divide the result by 10, and you will get the average of the 10 students. That's possible for you to do. But if I tell you, boss, inside your class, you have hundreds and thousands of students. Let's say you have 10,000 students in the class, right? And I want to compute the average marks of 10,000 students. Do you think it will be humanly possible for you or me to add up the marks of 10,000 students and then give the average? No, it will become a very boring and a tedious task for me to do that. So what will I do? In most of these situations, do you know what we do? We basically have some way of entering the data in an Excel sheet, right? I am telling you the very basic understanding, right? So you somehow feed the data inside an Excel sheet, right? And once you have the marks of, let's say, 10,000, 1 lakh students inside an Excel sheet, what can you do? You can simply apply formulas inside MS Excel, and you can compute the average, median, mode, or whatever you want to do. You can analyze your data in a very quick span of time, right? You feed the large chunk of data to your Excel sheet, and then you can perform data analysis in a very short span of time. So see how computers are helping me to reduce human effort. So I think all of us now agree when I say this, that boss, a computer definitely helps me to reduce human effort. That is the primary job of a computer. Is everyone understanding whatever I am telling? Let me just head back to the chats once. Just give me 1 sec. Yep. So is it clear till now? Is my voice coming fine? Yes, it's going fine, right? Cool. Cool. So I think we can continue. Right? Okay. Mute the chat. Okay. So what I will do for today, let's just disable chat, right? I have disabled chat so that all of you can focus on the class. Okay. And when I come back, I'll enable chat also, right? We will figure this out. Whatever is the problem from tomorrow, we'll figure it out. So for today, I think we don't have an option. So let's continue the way it is, right? Cool. I think the most important part is if you are able to hear me clearly and follow, I think that's fine. That's fine for today, right? It's mostly theoretical, so that's not a problem, right? So we understood that, yes, boss, out of these two terms, computer and programming, I have understood what a computer is. And the major takeaway for me was that a computer is an electronic device or a machine that is helping me to reduce human effort. Okay. So if I ask you, can you tell me some pros of a computer? Can you tell me how can a computer benefit me? Or how is a computer actually helping to reduce human effort? So I will tell you, boss, if I can think of the, the major plus points of a computer, I will tell that, boss, a computer can perform fast calculations. Okay. Calculations in a very short period of time. In a fraction of second, it can perform calculations. And do you know what part of the computer is responsible for computation? Okay. How are we able to do all these calculations in a such short period of time? The answer lies here. There is a component known as CPU. Okay, what is CPU? CPU is nothing but central processing unit, right? So think of the CPU as CPU is the brain of the computer. This CPU is nothing but it is the brain of the computer, and it is responsible for all the fast calculations that your computer is able to perform, right? So CPU is the brain and it is responsible for ensuring that calculations are carried out in a fast way, right? We get the results in as quick time as possible. Okay. The second pro that I can think of a computer, right? See, only using the computer for data analysis or, performing calculations is not sufficient, right? Now, 5 years down the line, you might want to reuse that data or reuse the insights that you developed from that data. So what is the second important point of a computer that I can think of? It offers you storage. Okay, it offers you storage. That is, you can store your important information inside computer and you can retrieve this important information at a later point of time, right? So a computer has storage, and what is responsible for storage? You have the primary memory and the secondary memory. We will come to all of these in details. So for storage, you can think of that, boss, my computer has two types of memory, right? You have the primary memory and you have the secondary memory. What is the primary memory? RAM. Okay, RAM is my primary memory. And what is the secondary memory? My secondary memory is nothing but ROM. Okay, ROM, or you can also think of it like the hard disk, right? जो hard disk होता है ना, HDD, hard disk drive. These are all examples of secondary storage. But what I want you guys to understand is a computer offers you storage and you can store important information inside the computer. So these are the two major plus points of a computer. But like any coin has two sides, right? If a computer has two plus points, it definitely will have a con also. Okay. So if I ask you what is a major con of a computer, what is the biggest pain point of computer, right? So the biggest con that I can think of, right, due to which we have jobs, okay, it is that, boss, a computer dumb. Now, what do I mean when I say a computer is extremely dumb? It doesn't know on its own what to do. You have to explicitly tell the computer what to do. You have to go and tell the computer that, hey, computer, you have to do this when the user does this. You have to respond like this in such a situation. Basically, the computer has no thinking power of its own. It is an extremely dumb machine. You have to go and tell the computer explicitly what needs to be done in different situations and scenarios, right? And fortunately, because of this con, we all are sitting here, right? Because we are the people who will be telling the computer what to do. Okay. So I think everyone must be clear with the pros and cons of a computer. But now you will come and ask me, hey, Adarsh, you are telling that a computer is a dumb machine. and I have to explicitly, tell the computer what to do. But do you know, Adarsh, what? I generally play games on my computer. I use my computer for sending mails. I use my computer for browsing YouTube, browsing Facebook, and whatnot. And I never had to tell the computer what to do. My computer was intelligent enough to do the things on their own. But this is not true. This is not true. Let me tell you what is happening actually behind the scenes. And then you will be able to better appreciate where we fit inside the picture. Okay. So you come and ask me that, hey, you know what, Adarsh? Let's take the example of mail. Okay. Let me take the example of a mail. So think of it that you are person A. Okay. This is person A. Forgive my drawing. My drawing is very bad. Okay. And there is another person B here. Okay. And you want to type a mail and send the mail to person B. So what would person A do? He will go open up the mailbox. He will type in the mail, whatever he wants to send, and then he will hit the send button. As soon as person A presses the send button, within a fraction of second, you know what will happen? Person B will get the mail in his mailbox. Now you will come and tell me, hey Adarsh, I didn't tell my computer how to send a mail. It was intelligent enough to figure out that and send the mail to person B. So how do you claim that a computer is a dumb machine? Now I will tell you, boss, you are the end user of the computer. Okay. Person A is nothing but the end user of the computer. And for this end user, all the tasks have been made very simple. For the end user, interacting with the computer is very simple. Person A does not need to worry what is happening behind the scenes and how is the computer actually sending mail. For him, the process is as simple as type in the mail, hit the send button, and I don't care, within 1 minute, person B will definitely get the mail. Okay. But do you know what is happening? Behind the scenes, there are persons known as software developers, right? There are people known as software developers. You know what they have done? They have written some explicit instructions for the computer. In the back end, they have written explicit instructions for the computer. Okay, I am trying to explain it in the most simple way that I can. Okay, so think of it like when the person A presses the send button, right? So there were software developers like you and me who have written the instructions for the computer that, hey computer, when the person presses the send button, you have to route the mail and send it to person B. Okay, whatever technical details are there, I am skipping that. But somebody has definitely written this set of instructions for the computer that whenever the send button is pressed, you have to go and send the mail to person B. Okay. So because these sets of instructions is available for the computer, it knows what to do when the send button is pressed. And therefore for person A, using this computer is very simple. Soch ke dekho, boss, if you would have to explicitly go and tell the computer how to send a mail, wouldn't it be very difficult for all of us to interact with the computers? Someone is from a commerce background, someone is from a humanities background, someone is not interested in how to talk with computers. Why do I need to worry about how do I speak with computers? Let the computer do its own job, right? So that is where people like software developers come into the picture. Okay, they will be writing explicit instructions for the computer based on which the computer will be running. Okay, take another example. I think all of you, not all of you, but most of you must have played games in your computer at some point of time or other. Okay. And let's take the example of a very common game, NFS, Need for Speed, right? It's a very popular car racing game. And I am pretty sure 50% of the people might have played it at some point of time or the other. Okay. So when you play NFS or when you play any car racing game, right? You are sitting in front of your personal computer and you press the keys in your keyboard. Okay. When you press the left key, the car goes to the left. When you press the right key, the car will move to the right. When you press the space bar, the car will basically brake. Okay. Have you ever wondered what is happening behind the scenes? No, I don't care what is happening behind the scenes. Ultimate end goal is, boss, when I press the left key, the car should move to the left. If it is not moving to the left, then it is a problem. So as an end user of this game, you don't worry of what is happening behind the scenes. For me, a computer is very intelligent and I am able to play games on the computer. But do you know what? There are people known as software developers, or let's say game developers, who have written explicit instructions for the computer, who have written instructions for this game NFS. They have developed the game and they have told that, boss, when the user presses the left key, the car has to move left by, let's say, 5 inches. Okay. When the user presses the space bar, the car speed should come down by 20 units. All of these things are explicitly told to the computer. The set of instructions is given to the computer. And that is how you are able to enjoy the game at your end. Now, who are these people who are writing these sets of instructions? They are nothing but software developers, right? All of us are aiming to get into that industry only, right? So where do we fit inside the big picture? We will be writing code that will allow the end user to interact freely with the computer without worrying too much about the technical details, right? So basically, if the computer would not have been dumb, then we would not have been sitting here writing instructions for the computer. Thankfully, the computer is a dumb machine, and you and I have jobs as software developers, right? I have, and you will be having within the next 6 months, right? So that is where we are fitting inside the picture. So I think I have convinced you enough that yes, boss, computer is an extremely dumb machine, right? Extremely dumb machine. So now you will tell, okay, computer is dumb, understood. So I have to give the computer some sets of instructions. I have to explicitly tell the computer what to do. And that is where I introduce the second term to you, which is program. What is a program? Okay. A program is nothing, but it is a set of instructions. Okay. A program is nothing, but it is a set of instructions that tells the computer what to do. As simple as that. I am using layman terms so that everyone is able to understand. What is a program? A program is nothing but a set of instructions that will tell the computer what to do. You are going and telling the computer, hey computer, when user presses left, then the car should move to the left. When the user presses the right button, the car should move to the right. So all these set of instructions which are telling the computer what to do, how to respond, this is known as a program. A program is nothing but it is a set of instructions that is telling the computer what to do. As simple as that. Okay, cool. Yeah, I think everyone should be clear. Okay, yep. So yeah, let's move a little bit ahead. Okay, so with the basic idea of the terms computer and program, right? I'm pretty sure that you must be now clear with computer and program. These are very fundamental concepts at the moment, right? Now, one another important term that I want to introduce all of you to is algorithm. Algorithm, right? Now, it sounds like a very fancy term, right? Algorithm. Bhai, kya heavy sa term bol diya aapne, meko pata nahi meaning, right? So it seems like a very fancy term, right? But it is a very, very simple term, and we need to understand what is the meaning of algorithm. Because when you go in the course now, you will hear this sentence very often. This algorithm is better than that algorithm. You know, my algorithm is better than your algorithm. So what is an algorithm? We need to understand what is an algorithm. Okay, so let me try to explain algorithm in the most simplest way that I can. So let's say that I give you 30 numbers. I give you 30 numbers, right? And I ask you, hey, can you please find the average of these 30 numbers for me? So what will be your process? What will be your thought process? Okay, Adarsh has given me 30 numbers. So let me add up the 30 numbers. I will sum up the 30 numbers. And let us say that I have summed up the 30 numbers and the sum is nothing but, let's say, 5,000. I have summed up the 30 numbers and the summation becomes 5,000. Then what you will do? You will divide the sum by 30. And when you divide the sum by 30, you will get the average of those 30 numbers. Okay. So I had given you a problem to solve. मैंने आपको एक task दिया. I gave you a task to solve. I told you, hey, can you please find the average of 30 numbers? And depending on the task, you figured out a way. You had your own steps. You had your own approach. You figured out the logic to find the average of 30 numbers. That, boss, in order to find the average of 30 numbers, what will I do? I add up those 30 numbers and then I divide the summation by 30. This is my logic, my approach of solving the problem. Okay. And I tell you, algorithm is nothing but it is your logic or your, the steps that you are taking to solve your problem. That is what is known as the algorithm. So algorithm is nothing but the logic that I undertake. It is nothing but the logic, okay, or the steps that I undertake to solve the problem that I have been given, right? So think of it like this. Think of it like this. Let me give you another example, right? So let's say I ask you, hey, can you please make a sandwich for me? Can you please make a sandwich for me? Right? If you know, it's well and good, but for a person like me, I don't know how to make a sandwich. Actually, I do, but for the sake of this class, let's think that I don't know how to make a sandwich. So what will be my idea? Boss, computers have made my job easier, right? With internet, YouTube. What I will do, I will go to YouTube and I will search how to make a sandwich in 5 minutes. And I will get a video, I will see that video and I will, follow the steps that are given in that video. So let's say that the step goes like this. Take bread. Okay, take bread. Then it will say, okay, apply butter. Okay. Then it will say apply cucumber. Then it will say, let's say apply tomato. And then it will say, okay, now your sandwich is ready to be consumed. Okay. So what was the task that I had at hand? The task that I had at hand was to prepare a sandwich. My job was to prepare a sandwich. What was my end goal? See, my end goal was to prepare a sandwich that is, eatable, that is suitable for consumption. Okay. And I started from the raw materials. I had the raw materials for the sandwich. And then I followed all these steps. I followed the steps that were told in the YouTube tutorial. I took bread, I applied butter, applied cucumber, applied tomato, and my sandwich was prepared. So this set, this logic that I have applied, okay, this idea or this approach that I have used to prepare my sandwich, this is nothing but the algorithm. This is my algorithm of preparing my sandwich. Okay. So this can be one algorithm of preparing the sandwich. Now somebody can prepare a sandwich in a different way. What he can do? He can take bread, then he can apply tomato, then he can apply cucumber, then he can apply butter. A different way of preparing a sandwich. So there can be multiple ways of preparing a sandwich. Somebody might not put in butter, right? See, the problem statement was one, prepare a sandwich. And the end result is also the same. You have to get to a sandwich which is edible or consumable, right? But there can be different paths or different approaches that you can take to prepare the sandwich. So each of these paths or approaches that you take, that is an algorithm. Okay, that is a different way or a different logic via which you are preparing your sandwich. So long story short, if I want to give you what is an algorithm, algorithm is nothing but the logic that you basically use to solve your problem and arrive at the final result. Okay, this is what is an algorithm, right? Cool. I'll just maybe switch once back just to check on you guys once. Okay, is everything going fine? If I can have a few response. Okay, sorry, I disabled chats. Wow, I forgot. Can you type in the chat now? Yes. Okay, cool. So it's going fine, right, for everyone? किसी को कोई doubt है? Any doubts that you have till this point of time? Any questions that you want me to answer? Anything? Anything? I think it's pretty basic till now. Okay. No doubts. Cool. So I think we are good to go. Okay. Voice is breaking. I am not sure why the voice is breaking. We can think of it once. We can see what can we do, right? But I think, yeah, if you are able to follow, then it's fine, right? Okay, cool. So I am turning off the chats once again. Chalo. Cool. So let's come back once again here and try to focus, right? And see, all of these are to get you guys started, right? To get you guys a flavor of what we are going into, right? So I'll explicitly tell you where do you need to focus more, where do you need to focus less, right? For the first lecture, it's mostly all theoretical concepts, right? So just sit back and watch it like a movie. Try to understand as much as you can, right? It's pretty simple, and just relax, karo guys. Okay. Just chill and try to understand whatever is being covered. Again, it's very important and fundamental at the same point of time, right? So now I understand what an algorithm is. Okay. So I tell you one simple thing, boss, you know what? The program that you are writing, we all understand now what a program is, right? So any program that you write, that will consist of two parts. Okay. So you are writing a program to solve a particular problem, right? You are facing some problem and you are writing a program to solve it. So my program will be consisting of two parts, right? When I want to solve any problem, first of all, I need to figure out what is the logic. Boss, I had to make a sandwich. First of all, I have to look at the YouTube video and figure out the steps via which I can make my sandwich. So the first important part of any program is the algorithm. You need to have a fundamental logical understanding of what you want to do. How do you want to solve that problem? And once you have understood how do I solve the problem, then you will go and convert this algorithm into code. You will convert your logical idea into instructions that the computer can understand, right? So this is the two major parts of any program. The first part is, first of all, figure out the algorithm. That is, boss, what will be the logical way of solving this problem? Once you have figured out, yes, I will attack and solve the problem in this way, then you can go and convert your algorithm into code, or you can convert your algorithm into instructions which the computer can understand. Okay. Now let's come to another important understanding, right? Now, so far, I have been telling you that, boss, a computer is a dumb machine. You will be telling the computer what to do. So it is like you are the master and the computer is your slave. Okay. So you have to communicate with the computer in order to, so that the computer understands what it needs to do. Okay. So I am telling you one thing. Okay. Tick tock, tick tock, tick 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 tock. I am pretty sure none of you understood this, right? And I just took whatever came into my mind, right? What I want you guys to understand is, if I want to convey my thoughts to you, I should definitely not use a language which you don't understand, right? If I say, you know what I will be teaching? I will be teaching, take, talk, talk, take, talk, whatever. You will not understand what I am telling, right? Because I only know what I am speaking, right? In order for you to understand, I should speak in a language that both of us understand. In this case, the language of instruction is English, because I can also understand English and you can also understand English. So you will then get a question that, boss, you told that you have to interact with the computer. You have to write instructions for the computer. But then I will definitely have to write instructions in such a way that I also understand what I am writing, and the computer is also able to understand what I am writing for it. I think everyone agrees on this, right? Think of it like this. Think of it like this. Okay, yeah. So basically, you have to write the instructions in a language that the computer also understands. Because if the computer is not able to understand what you have written, then how will it execute all your instructions? It won't be able to do. So we have to agree upon a language, right? We have to choose a language with the help of which we can talk to computers, right? Now, what should that language be, right? I give you one option. Can I take English as the medium of reference? Can I take English as the medium of reference? I know that you guys don't have access to chats, but I am pretty sure most of you will be saying, no, I won't be talking to the computers in English. Why? Let me give you a very simple reason why I won't use English to talk with the computers, right? We know English, right? But computers is something that is being used globally, right? So in some countries, some people might not understand English. Okay, some people might not even know what English is, right? So English cannot be used globally for talking to computers. Number two point can be, English is a very funny language. Okay, English is a very funny language. If you have watched the movie Bol Bachchan, you will be able to understand. Yeah, उसमें बोलता है ना अभिषेक बच्चन, English is a very funny language. I can talk English, I can walk English and whatnot. What I want you guys to understand is, English is a very ambiguous language, right? If I want to put it in those ways, right? So if I ask you, wow, good job, right? This is one tone. And if I tell you, wow, good job, okay. See, I don't know if I have been able to express myself clearly or not here, but what I want you to understand is, the same sentence can mean different things when used in a different tone. Okay, I can say the same sentence in a sarcastic tone, and I can say the same sentence in a happy tone. It is a very ambiguous language, right? English is a very funny language. You and I don't understand. See, we understand because we are able to communicate verbally. But if I'm writing text down in English, then it is very difficult for the computer to understand whether you are praising the computer or whether you are scolding the computer, right? So definitely English is a big no. Or for that matter, any language that humans converse in, that is bound to be ambiguous. And therefore, computer is already dumb and you don't want to, put some extra load on the computer. So definitely I can't, speak or talk to the computers in English or any language that you and I actually converse in. So I have ruled out this, this possibility. So what do I actually talk, or how do I actually, convey my instructions to the computer? So I will tell you one thing, right? So a computer is nothing but an machine, right? It's an electronic device or a machine at the end of the day, right? And people who are from an electronics background, right? And even if you are not, it doesn't matter, right? So you would have understood that yes, a computer is made up of semiconductors, capacitors, diodes, transistors, and all these electronic, equipments or devices. Okay. And because a computer is an electronic machine, it understands only zeros and ones. Okay, computer can only understand charged and discharged. There are only two states inside a computer, right? All the transistors, MOSFETs, and the devices, they can either be charged or discharged. So what I want you guys to understand is a computer at the end of the day only understands zeros and ones. This is what a computer understands at the end of the day. And this language consisting of only zeros and ones, which the computer understands, we call it as the binary language, right? So computer understands binary, or we can also call it as the machine code. And why am I calling it binary? Binary means two. See, either you have a zero or you have a one. There is only two possibilities, right? So a computer is an electronic machine or an electronic device, whatever you want to understand. And the computer at the end of the day only understands zeros and ones. That is binary language or machine code. So you will tell me, okay, problem solved. Boss, you know that the computer understands binary. So let us start coding in binary. Let us start writing instructions for the computer in binary, right? Now, do you think that writing in binary will be a very convenient task for you and me? Definitely it won't be, right? It is easy for the computer to understand, binary, but definitely for humans, it is not possible to write code in binary because it becomes very confusing, right? And we humans also have our own ego, right? मैं बोलूंगा, why do I bend down to the level of the computers? No, I will not write in binary. You know what the humans do? What we do today is we understand that, boss, writing in binary is very, very difficult. It is not an easy task to write code in zeros and ones. Okay, hands down, you cannot code up in zeros and ones, right? So हम लोग बोलते हैं, boss, we can arrive at some other understanding. You cannot use English, and I cannot use zeros and ones also at the same point of time. So I tell you, boss, I introduce you one term which is known as HLL. I call it as high level languages. The task is to communicate with the computers, right? I have to write language with the computer understands. So I will tell, boss, I will be writing my set of instructions in high level languages. And what is high level language? High level language is more closer to us than closer to the computer, right? Looking at the high level language, you can easily understand what you want to tell to the computer. It is easier for us to understand high level language. Okay. And at the same time, high level languages are not ambiguous like English, Hindi, or whatever language, right? So what are some examples of high level languages? Java, C++, Python, Golang, all these programming languages that we write code in, those are known as high level languages. Why high level? Because it is closer to us than closer to the computer. It is simpler for us to understand high level languages than it is for the computer. So we write all our code in high level languages, which is easier for us to understand and easier for us to write. Okay. Now you will come and tell me, boss, okay, you have written code in high level language, but you will have this doubt that, bhaiya, I don't know how many of you have seen Java before, but in high level languages, now you write something which you can understand. Definitely you don't write zeros and ones. So you will come and ask me, boss, you told that the computer understands zeros and ones, and now you are coding in high level languages. So how does the high level language actually, gets converted to zeros and ones? Boss, computer doesn't understand Java. Computer at the end of the day understands zeros and ones only. So let me take a very practical example and you will be able to understand what happens, right? So let's say you are in a foreign country. Okay, let's say you are in a foreign country. Okay, you are person A, you are in a foreign country and you know only English. You know only English. Okay, and let's say that the country you are in, the people of that country only know Spanish. Okay, So tell me, if you tell anything to this person, will this person be able to understand what you are telling? Never. And if this person replies to you also, now you will not be able to understand what is this person telling. There is a gap created between you and this person. Similarly, high level language is not something that the computer actually understands. So can you tell me what comes here in between? I know that most of you will understand what is coming here in between. I will take help of somebody known as a translator. I will say, hey, translator, this translator is a person who understands both the languages. Okay. So I will tell whatever I want to the translator. The translator will convert my English to Spanish and tell to this person. The person responds back to the translator. Translator will convert this back to English and tell me. See, guys, without this translator, I cannot communicate with this Spanish guy. But with the help of this translator, I can communicate effectively with this Spanish guy and we both can understand what we want to do. So similarly, do you agree that there has to be some sort of a translator for a computer also? Because you are writing code in high level language and the computer at the end of the day understands binary. So there has to be some entity in between which will be converting this high level language into binary so that the computer can understand what you want it to do. And this translator, which has the job of converting this HLL into binary, let me call it as the compiler. I call it as the compiler. So what is the compiler? If I want to understand it from a very, very top level view, I don't want to go into technical deep dives at this moment. But yeah, if I want to understand it in a very, very layman's term, right? A compiler is also a software, right? Compiler is also developed by people like, you and me, okay? Like software developers to be more precise, right? So what is a compiler? A compiler is a software entity which will convert my high level language, okay, which will convert the code that I have written into high level language into binary or machine code which the computer can finally understand. Okay, but again, this box is not as simple as a one step process of converting from HLL to binary. Okay, this entire process is also involved. There can be multiple stages, okay, in which the high level language gets converted to a binary. But for us, at this point of time, a compiler is nothing. It will convert my high level language into, at the end of the day, binary code, which the computer can understand. Okay. So that is where we come to the concept of compiler. Okay. Cool. I think I'll just, say a couple of more points and then we can discuss, right? Okay. So we understood what a compiler is. Okay. Okay. Now my job is to understand high level languages. What are we going to do in this course? In this course, we are first going to study about high level language Java. Okay. In this module 1 specifically, we will be developing our understanding on Java, trying to solve some basic problems using Java, right? And then we will go on to data structures and algorithms, right? So we want to learn HLL, right? And just now I told that, boss, there are multiple high level languages available. Java is there, C++ is there, Python is there, Golang is there, and there are multiple languages that are available for my selection. So then you will come and ask me, hey, why are we doing this course in Java? Why not C++? Why not Golang? Why not Python? Why not XYZ? Right? So if I want to give you a very concrete answer of why Java, right? First of all, Java is a very universal language, right? It's used across companies. And to be very honest, one of the big reasons would be most of the companies, okay, widespread opportunities are available in Java development, right? Java, almost every second company you find that will be using Java in their tech stack. Golang, on the other hand, is a new language, right? And the opportunities for Java is generally more. So that is one of the reasons why we use Java in this course. Another reason, if I want to give you some plus points of Java, okay, number one point is Java is a very secure language, okay, and this is one of the parts which you can skip, or you can take lightly at this point of time, right? I'll explain to you all, but as the course progresses, you will understand it in more detail. Java is a very, very secure language, right? It gives you much more security over the code that you are writing. Okay, how does it secure my code? How does it prevent unauthorized access to my code? All we will see when we discuss about OOP. So Java is a very secure language because entire Java language is based on the principles of object-oriented programming. But I think you have to, unleash, you just have to pause your curiosity for this time, right? Because it's not the right time for us to discuss OOP at this point of time, right? So Java is a very secure language. You have to take my word for it at this point of time because of object-oriented principles. Okay. The second point is like, I won't say it as a point, but Java is like a fast language, right? It's fast and it's comparable to C++ and the other languages out there. Okay, so it is a fast language. Okay. The third point is Java is platform independent. You know what? Java is platform independent. And I will tell you what do I mean when I actually say that, boss, Java is platform independent. We will understand this also, don't worry. Right. So if I want to understand what do I mean when I say that Java is platform independent, or Java is a very portable language, portable. It can be run across multiple platforms. What do I mean when I actually say this, right? So let's go back to discuss the compilation process in Java, right? And if you understand the compilation process in Java, it will be somewhat easier for me to make you guys understand the platform independent thing of Java. And then I will take questions after this part, right? So what did I told you guys? I told you guys that, boss, you will be writing your code in Java. So let's say you open up a text file. Okay, you open up a text file. You write your code in Java. Let's say system.out.println, whatever you write your code in Java. Okay. Now, whatever source code, see the original code that we write now, I call it as my source code. This is the code that I have actually written. Okay. And whenever you write code in Java, right, you save your files via .java extension. So let's say I will call it lecture1. Okay, I want to call this document lecture1. So I will save this code as lecture1.java. Okay. So let's say I have written up my code. I have written up my source code, right? And I have saved, the file as .java extension. Okay. So now my computer recognizes that, boss, this is a Java file. Okay. Now, but simply writing this Java file is not sufficient, right? Ultimately, somebody has to work on this HLL language and try to convert it into machine code so that the computer understands, right? So there we come to the concept of a compiler. Okay, and how does this process actually work in Java? That is important for us to understand. So you have your source code, right? You have your source code. Now what will happen is the compiler will act on this source code. Think of this, that, boss, your compiler is a man. Think of it like this. Ekdam simple mein samjha raha hu, theek hai? The compiler is a person who will be acting on this source code, and this source code will be converted into something which we call as the byte code. Okay. See, मैंने क्या बोला था? You write the code in HLL and it gets converted to binary, right? And the job is of the compiler, but the process might not be as simple as direct conversion from HLL to binary. There can be a series of steps involved in this conversion, right? So the source code that we are writing, it is the normal Java code that we are writing, and we save the files like, with .java extension. Okay. Now, once you have saved the file, then you will say, hey, can you please compile the file? Okay. So I don't know if you have seen it before or not. There is a tool known as Java C. Okay. Java C is my Java compiler. So I will compile this code, and what will the compiler do? The compiler will convert this source code into something known as a byte code. And what is the byte code? Is byte code same as the binary code? No. Byte code is not the same as binary code. Think of the byte code as somewhere in between HLL and machine code. Okay. Think of it like byte code is somewhere between source code and the low level code or the machine code of zeros and ones. Okay. So what will happen is the compiler will convert my source code into byte code, and these will be nothing but .class files. These will be .class files. Okay. Think of it like something like this. Think of it like something like this. Okay. Okay, boss, let's say you are writing a code for adding two numbers. Okay, I am trying to make it as simple as I can. Okay. So let's say I write code. अभी तुम लोग को नहीं समझ में आएगा. I don't think you'll be able to understand, but yeah, some people will definitely be able to understand it, right? So let's say I write the code for adding up two numbers, right? So I write int sum is equal to a plus b, and then let's say I write system.out.println sum. So I have written a very basic Java code for printing the sum of two numbers. Don't worry if you don't understand it at this point of time. We will go into it in details, right? But what I'm telling you, let's say you write a source code. You write a source code. When I compile it, my compiler will basically convert it into byte code. And think of the byte code as it is some sort of an intermediate code between source and zeros and ones, right? So think of it like my code can look something like this at this point of time. ADD AX, 5, ADD BX, 10. Let's say if A has a value of 5 and B has a value of 10. Okay. So it is some sort of an intermediate code. It is some sort of an intermediate code. And you have identified it correctly. This code is definitely more closer to the computer as compared to me. It is somewhere in between, right? It is somewhere in between. It is not as simple as understanding. Dekho, you will understand that yes, you are adding something with 5. You are adding something with 10. But then you will ask me, what is AX? What is BX? So what I want you guys to understand is bytecode is somewhere in between the source code and zeros and ones, right? You can understand bytecode, but at the same time, it might be difficult for you to actually interpret what bytecode is, right? Think of it like bytecode is like a universal file. Okay, it will be common across multiple platforms. So this is telling me what is it that is expected for the program to do. I am giving a very brief and a very overviewistic example, right? So it is telling me add AX comma 5, add BX comma 10. This is what the bytecode is telling me. And it can be something like this also, right? ऐसा भी हो सकता है. You can see something like this. 0x45. Let's say this stands for add, right? And again, the second line can be 0x410. So add 5, add 10, something like this, right? So bytecode is not very simple for us to understand. But one thing good about bytecode is, you can take this file. See, this is an executable file. This is an executable file. Now you can take this file on any platform that you want, right? Let's say I have written the code on a Windows machine. Okay, on a Windows machine. I don't care. You can take this bytecode. See, you write the code, you compile, you get the bytecode. You can take this bytecode file on any platform that you want. You can take it on a Linux platform. You can take it on a Mac platform. You can take it on any platform that you want, anywhere. On any computer, you can take this executable file and then you can run the same file on any computer. And that is why we say that, yes, boss, Java is a platform independent language. You write the code on one computer, you compile it into bytecode, and then you can take this bytecode into any of the other platforms. You can take it into any other machine and you can run your bytecode there. It is platform independent. It doesn't depend on what platform you have created your bytecode on. Irrespective of what platform you have created this bytecode, you can run it on any platform of your choice. Okay. So how does it run? How does it run? See, I will not go into the technical details, and we don't have to worry about all these at this point of time. But there is something known as a JVM. What is JVM? JVM is a Java virtual machine. Now think of it, this is another person. Think of it, this is another person. Now, when you bring your bytecode onto a platform, and when I run this bytecode, what will happen? JVM will basically act on the bytecode. This person will act on the bytecode and it will interpret what is written in the bytecode. It will convert the bytecode into zeros and ones. Okay. So let's say 0x4 means add, right? So see guys, it can be something like this. Let's say you are on an AMD processor. Okay, you are on an AMD processor. Then add might mean 0011. Okay. See, all these codes are dependent on what kind of processor and what kind of environment you are on. Okay. And let's say for an Intel processor, addition का formula क्या है? 0111. 0111 means add. Okay. So what I want to do, boss, bytecode is the same. You bring this file on any platform. And when you run the file on this platform, what will happen? The JVM will basically convert this bytecode. It will interpret this bytecode and convert it into binary language which the computer understands, and it will be finally running that, right? So most of the people have this question, right? Is Java compiled or interpreted? I will say it is both, right? So see, there is a process of compilation also involved. I am compiling the source code into bytecode, and then you can move this bytecode into any platform of your choice. And when you execute the bytecode on this platform, what will happen? There is an entity known as JVM. It will run and it will interpret or convert this bytecode into stream of zeros and one at the runtime. Okay, so Java is both compiled as well as interpreted. JVM will be interpreting the bytecode during runtime of my program. Okay, so this explains the platform independent part of Java. You write your Java code on any machine, you can take your bytecode and run it on any other machine. Okay, this is what I wanted to make you guys understand when I say platform independentness, right? Now let me come back to the chat and let's take some questions maybe. Give me 1 second. Yup. Yep. So, how many of you are able to follow along? Is this making sense, what I'm trying to say? Got it. देखो, JVM, JRE, JDK, we don't want to go into the details, right? At this point of time, we don't want to understand what is JVM, what is JRE, what is JDK, all these architectures we don't. हम लोग को जाना ही नहीं अभी, ठीक है? मैं बोला ना, I will tell you what to focus, what not to focus, right? At this point of time, we don't have to focus on what is JVM, what is JDK, what is JRE, nothing of that sort, right? You will understand it, when time comes, and I'll definitely tell you when it is, needed. Can you repeat platform independent feature? Okay, I'll repeat it. Okay. Also there, C++, no one is comparing the runtimes here, right? So let me just repeat the platform independent feature. Okay, so let's say I'm writing a very basic code, right? Let's say I'm writing a very basic code. Int a is equal to 5. I'll tell you all these things later, right? Don't worry. Okay, so let's say I write a very basic code of adding two numbers, right? So let's say I have written this code. Okay, I have written this code on, let's say, Windows, and let's say AMD processor. This is my processor, right? I've written this code. I compile it. I will get a bytecode. Okay. For your understanding, see, bytecode is also something which we won't be able to understand. If you open a bytecode now, you won't be able to understand what is written there. But let's say somehow, for my understanding, I tell you, this will be written add, let's say 5, add 10, RET, result. Okay. Let's say this is the bytecode. I'm just giving you a very, very basic idea, right? This is the bytecode that has been generated. Now, guys, try to understand. This bytecode will remain same for all the platforms. Okay. I can see. Let's take two cases, right? I have a platform, let's say with the AMD processor, and let's say you have another platform with Intel processor. Now, you agree, right, that all these additions, subtractions, and all these are operations, right? So the people who have developed Intel chips, they might have coded inside this chip that, boss, for addition my code will be 000101. This will be my code for addition. Whenever you write this code, it means addition. Okay. And for AMD, the people might have written that, boss, 010100 is addition. This is what means addition. Okay. So now what will happen? See, boss, this is a byte code, right? This is not saying zeros and ones. Okay. So I can place this byte code on any platform. I can place it on an AMD processor platform also. I can place it on an Intel platform also. I can place the same file on any platform that I want. Okay. Now, when I run this file, when I run this executable file, what will happen? There is a person known as a JVM, right? There is a person, and this person will interpret. It will interpret line by line what is written in this bytecode. So what is the first line? Add 5, and it will see that, boss, I am running on an AMD processor. So what does add means? It will say, it will tell to the computer 010100, and let's say it tells somehow 5. Okay. Then it will tell 010100. Let's say 5 को मैं लिखता हूँ 101, right? Then it will tell, let's say, add 10. Okay. And for red, the opcode might be 000011, and let's say result, whatever, right? So these are the set of instructions that my JVM is converting the bytecode into. Add 5, add 10, return result, right? But when you run the same bytecode on an Intel processor, right? This instruction, do you agree that 010100 might stand for a different thing in an Intel processor? Intel ke liye, this might mean multiplication, right? So definitely you can't run the same binary code on Intel. This will give you wrong results, right? So what I tell you, you just place this bytecode onto this Intel platform. Okay. And when I run this bytecode, what will happen? JVM is a person. He will see that, boss, you are running on Intel. Okay. So what is the opcode for add? Add is nothing but 000101. So it will convert into binary code for the computer. 000101. Okay. Add 5. Then it will tell 000101. Add 1010. So are you getting what I'm telling? the instructions, the binary code that the computer receives at the end of the day, that will be different according to different platforms. But bytecode is platform independent. You can place this bytecode on any platform, and then the JVM of that platform will take care to convert this bytecode into machine code that the computer can understand. Is this making sense? Yeah, all these will be shared with you also. You don't need to worry on that front. Right, correct? Okay, cool. Hey, Hemant, I think for the doubts part, I think this is how I think somehow. Bytecode and assembly code, are they the same? Okay, so you can treat them as the same. Ideally, they are not the same, right? They're not the same. But yeah, if you kind of understand high level language, intermediate code, if you are calling it assembly, then yes, you can think of it like that. Okay. Bytecode and binary code. See, binary code is basically a stream of zeros and ones, right? Binary code is nothing but 0 1 0 1 0 0 0 0 1 1 0 0. But bytecode is not binary. Bytecode is somewhere, let's say hexadecimal or some other format, right? It's not Java, but at the same day, it is not zeros and ones. Okay. What is AMD? AMD is a brand of a processor. Okay. So how many of you have actually got a decent idea of what is happening in the class? कितने लोगों को समझ में आ रहा है क्या चल रहा है? I think going slowly. Okay. Chalo, cool guys. I think most of you are clear. I think I can take more doubts a little bit later, right? How compilers are written, boss, no need to understand, right? You have to, undergo a course known as compiler construction in your college for that. Okay. ठीक है, मैं एक बार stop करता हूँ. Let's go back. Let's go back. Okay. So far so all. I think and see guys, again I told you ना कि lecture में it might not be possible for me to मैं repeat करूंगा, ठीक है? I'll definitely repeat as much times as I can, but I will also expect that at the end of the lecture ना I will provide you reading materials. Okay, I'll share links with you where you have to go and read up, right? So I will expect, okay, I don't expect you to understand everything in the first day itself on the same lecture, right? But what I will expect from you all is whatever things that I share after the lecture, right? Whatever assignment problems, whatever theoretical stuff, whatever articles for reading, please read them after the lectures and then see if you generate more doubts or you get more clarity, right? So if you get clarity, that is good. If you generate doubts, more good. We will try to clarify them, right? So this is how the flow will be going on. So yes, I know everyone will have questions, right? But I will first suggest try to, attend the entire lecture, see what all doubts you have, write them down in a piece of paper. Then whatever links and articles I share at the end of the class, go through them, see if that solves your doubts. If not, try to Google up, interact with your peers. No help, definitely we'll discuss it in the next lecture. What I am trying to make sure na ki you also become a little bit independent, right? Everything if I start telling you and giving spoon feeding you, then you will not be able to Google up and understand things on your own. Okay, so I am there to help you, but at the same point of time I also want to make sure that you guys are also independent and you also read things on your own and try to understand, right? That way it will be easier for me also and for you guys also, right? So far I have convinced you that yes, Java is our go-to language, and even if you guys are not yet convinced on these 3 points of Java, I think still we have a very big point that most of the companies have open Java roles. So anyways, we will be doing Java in this course, right? But I think with this idea, you get a basic idea of the compilation process in Java as well. But yeah, don't put your heads too much into it. Try to read over it once, try to understand it once. If you understand it, fine. But even if you don't understand it at this point of time now, you will understand it as the course progresses, right? Because at this day you are not that mature, but जैसे से course progress होगा, you solve problems, you read up stuff on your own now, you will become mature with every passing day. Okay, cool. So now we discussed about the language. Now you will tell, chalo boss, now let's go and write code, right? Now let's explore the Java language, right? So before I go and write code in the Java language, I just want to, highlight a couple of other things, and then we'll definitely try to, write a code and try to understand things from there, right? So now we have come to a computer program. I know what a computer program is. I know what language I will be writing my code in, and I understand what is HLL, what is bytecode, what is machine code, and how this conversion is done with the help of a compiler. So long story short, I don't have to worry about all these internal details. I am happy coding up in HLL, and I know that boss compiler is my friend, and it will ensure that yes, the computer gets a stream of zeros and ones which it is able to understand at the end of the day, right? So what are some of the important parts of any computer program, right? So what are like some of the very important parts of any computer program? So whenever you write a program, right, you are basically trying to solve a problem. Okay, you are writing some code to solve a problem. And whenever we write code, now one of the things that you will see that you always have some sort of a data is essential, right? You interact with the code. Maybe you will be dealing with numbers, maybe you will be dealing with names, maybe you will be dealing with alphanumeric entries, right? But definitely you will have some sort of data to deal with, right? So let's say you are writing code, right? And let's say you have a data 55, right? So what you can do is, one way can be you write 55. Let's say I'm writing code, right? And I want to add 55 multiple times. So you can keep on writing 55 every different where in the code, but that is not a very good practice. Okay, I don't want to repeat this same 55 again and again in the code, right? So the first very important component of any computer program that we want to understand is something known as variables. And what are variables? Variables are the same as we have studied in maths, right? I think all of you here have some decent knowledge about maths, right? So if I ask you f of x is equal to x square plus 5, okay, I've written a function f of x is equal to x square plus 5. And I tell you, boss, x is equal to 5, okay? And then I tell you, hey, do you know, can you tell me what is x plus 5 minus 10 plus, let's say, x square? So you understand one thing, that when I tell you x is equal to 5, you automatically understand wherever I am writing x, I need to plug in the value of 5. I think everybody understands. X is a variable, right? X is a variable. If I write x is equal to 5, wherever I see x, I will be plugging in the value 5. If I say no, x is equal to 10, so wherever I see x, I will be putting in the value 10. Okay, so similar to the concept of variables in mathematics, we also have variables in programming. Okay, we have variables in programming. And what do variables do? Same thing as maths. Variables basically contain data. Think of it like variables are your containers. Okay, they will store data for you. So one of the very important parts of my program is variables. You can store your values inside the variables, and then you can refer to those variables at different places in your program. So the first important part that we will understanding is variables, right? Now, after variables, I'll go to details of all the things, don't worry, right? So after variables, the second important part that I want you guys to understand is any program will have an algorithm. Do you all agree with me? Any program will definitely have an algorithm. Boss, without an algorithm, program cannot exist, right? This is more of a mental thing, right? We will have an algorithm in our mind, but definitely algorithm is also a fundamental building block of any program that you write, because without an algorithm, there cannot be any program or code, right? So algorithm is the second important part. The third important part is something known as, control flow. We'll be looking at this in module 1, don't worry. Control flow or control block. Now what do I mean when I say a control flow or a control block? So you will see that whatever code we write, okay, मैं जो भी code लिखूंगा ना, whatever code I write, generally the sequence of execution is sequential. Let's say I write a code, okay, so this is line number 1, line number 2, line number 3, line number 4, line number 5, line number 6. So I have written some set of instructions for the computer. So in general, when I run this program, do you know what happens? You have a sequential flow of execution. You have sequential flow of execution inside computers. What do I mean when I say sequential flow of execution? First of all, line number 1 will run, then line number 2, then line number 3, then line number 4, line number 5, line number 6. So the lines will be run in a sequential fashion. Okay. But you don't always want your lines to be running in a sequential fashion. You don't want that, right? You want some kind of a control over the flow in which a program is executed. I need to control how the flow of the program is actually operating. I might want ki boss execute line number 1, okay? Then if today the weather is sunny, I want to execute line number 2. If the weather is rainy, I don't want to execute line number 2. What I want you to understand is you don't always want sequential flow of execution. Okay, you might want to take certain decisions. Ki boss, I don't want to execute line number 2, or I don't want to execute line number 3, or I want to execute line number 400 times. Right? You need to take all those decisions as well. So those are basically introduced with the help of control flow or control blocks. What will the control flow or control blocks do? Control flow or control block will help me to control the flow of execution of my program. And I think you must have understood it correctly. If you have, control flow में क्या चीज आएगा? Loops and conditionals. These are the two very important control flow or control blocks that we will be discussing in module 1. Conditionals and loops, they will be helping us to take decisions, right? And they will be helping us to execute some statement multiple number of times. Okay, so these are the three basic building blocks of any computer program, right? Cool. Now, so I think everyone should be clear, right? Variables, very simple. They will be storing data. We will see examples as we write a code. But yeah, variable is nothing but it is storing data, and you can refer to that variable later on in your code. So let's say somehow I tell in my code x is equal to 5. So whenever I write in my code x, I know that the value 5 will be substituted for x. That is what is a variable. Algorithm, very simple. Logic in which you write your program. Okay, and control flow will be you have these certain elements known as conditionals and loops, which will give you more control over your program. And it is not always the same boring way of line number 1, line number 2, line number 3, right? You need to have some more control over your program. Okay, so these are the three basic building blocks, right? So now before I move to the code, okay, before I discuss something about the code, let me discuss something about memory. I think it's important for all of you, especially the non-CS guys and the non-tech guys. It's important that you understand what exactly is memory of a computer, right? So whenever I say memory, okay, just give me 1 second. I'll drink some water. Just give me 1 sec. Okay, so whenever I talk of memory, right? So memory, when I say memory, right, I mean to say primary memory of a computer. Okay, unless explicitly I tell you I am talking about the secondary memory or the hard disk or the whatever hard disk drives or the SDDs, I am talking about my primary memory. Okay, and what is the primary memory? If you recall, primary memory is RAM, random access memory, right? This is RAM. Okay, so my RAM is my primary memory. And how do I visualize how my RAM looks like? So for people who are new, okay, you can imagine your memory to be something like this. Just imagine your memory to be a two-dimensional grid. Just imagine it like this, right? You have these grids, a two-dimensional grid, and this is as simple as this, right? Just imagine your memory, right? You don't have to go and design a memory, right? अपन को क्या करना है? We just have to understand it in the most simplest terms so that we are able to get the basic idea and we are able to write code ourselves, right? So if I want you to give you a very overview understanding of what is a memory, think of the memory like a two-dimensional grid, right? And there are multiple cells in my memory, and in each cell you can store certain information. You can store some data inside your cell. Okay, now let's say that you write something like this. मैंने बोला था ना variables store data. I told ना variables contain data. So it's something like this. Think of it like this. When I write something like a is equal to 5, you know what will happen? I'll tell you. What will happen is, let's say this block will be reserved. Okay, this block in memory will be reserved. Okay, the data 5 will be stored in this block, and you know what will happen? A will be pointing to this particular block. Okay, so whenever I say, hey, can you print the value of A? You know what will happen? 5 will get printed. So think of it like, you can understand your variables like this. Ki boss, you store the data inside your memory, and variable is nothing but they are pointing to that particular container. Okay, a variable is nothing but a label A label. It is pointing to the container in which my data is stored. So when I say print A, I know that I am talking about this particular container, and I know that 5 is stored in the container. So 5 will be printed. As simple as that, right? Now, so if I write, let's say B is equal to 10. So what will happen? Let's say this block will be reserved. 10 will be stored here, and B will be pointing to this particular block. So whenever I do print B, or whatever, B plus something, so automatically I know that B is pointing to 10. So B ki value 10 hogi. Okay. So nothing, right? So as simple as that, the memory is consisting of multiple grids. You can store your value inside your grids, and variables are nothing but they are labels. Okay, they are labels pointing to that particular container where your data is stored. Now you will come and ask me, see, you can also imagine your memory to be like a two-dimensional street layout. Okay, there are multiple houses. Each of these grids is a house, right? Now you will tell me that, boss, a house can be identified by its address. How do I know that I am talking about this cell? How do I identify a cell in memory? So I will tell you, boss, every cell in your memory has an address. Okay, every cell has an address. We won't go into the details. So let's say this cell can have an address, let's say 1000. This cell can have an address 1001. This cell can have an address 1002. This cell can have an address 1003. So every cell has a particular address inside memory. Okay, so you can go to a cell if you know the address of that particular cell. But again, these are more involved, and we won't be going much into the details at this point of time. Okay. Now the question that most of you should be having at this point of time, ki boss, you stored 5 in this particular grid, you stored 10 also in this one grid. Okay, now what if I want to store my name Adarsh? Let's say I want to store my name Adarsh. Can I store it in one grid, or will I need two grids? आ रहा होगा ना ये सवाल. 5 तो हट गया, 10 हट गया, right? 5 fitted inside, 10 fitted inside. Can others fit inside one or not? You must be having this question, right? So the fundamental thing for us to understand is, what is the unit in which we measure memory? What is the unit in which we measure memory, right? And the fundamental thing that you have to understand is, the computer at the end of the day understands only zeros and ones. So even if I am showing you, boss, 5 is stored here, you will understand that all the data is stored in only zeros and ones. I am just printing or writing 5 here for your understanding. When I say 5 is stored at this location, ultimately 01010 ऐसा कुछ store हुआ होगा, which will say that the data 5 is stored here. Okay, so the fundamental thing that we want to understand, or the fundamental unit of memory, is a bit. A bit. What is a bit? What is a bit? A bit is basically a short form for binary digit. Bit is nothing but a short form for binary digit. And what is a binary digit? Either 0 or a 1. So 1 bit means either a 0 or a 1. So when I just write a 0 or a 1, it means 1 bit. Okay, so 1 bit means either a 0 or a 1. Okay, now let's say I need to store 5. I need to store 5, right? So I will tell, boss, you need to represent 5 in binary. So let's say I tell you that 5 is nothing but this 101. I tell you, abhi ke liye just agree with me, right? Let's say I tell you that, boss, 5 is 101. So can you tell me how many bits I need for storing 5? How many bits do I need for representing 5? I need 3 bits. Do you all agree? If I say that, boss, 5 in binary is 101, then I need 3 bits. Dekho, this is 1 bit, second bit, third bit. I need 3 bits to represent 5, right? So what I say, bit is the smallest unit of measurement. Okay, 1 bit is simply one binary digit, either a 0 or a 1. Okay, so the space in which you can store one digit, either a 0 or a 1, that is known as 1 bit. Okay, now I am telling you, boss, for representing 5, you need 3 bits. Okay, similarly, I tell you, boss, you know what, 8 bits make up a byte. I think most of you would have heard it, right? 8 bits make up a byte. Okay, so let's say if I am storing a number like this, okay, 8 bits, right? So I will tell, boss, I need 8 bits inside your memory. That is, I need 1 byte of space inside memory to store this particular number. So 8 bits will be making up a byte. Okay, so let's assume that every cell is 1 byte. Let's assume for now. Okay, if you want to be more granular, you can imagine that these are 1 bit. Every cell can store 1 bit. But let's say that for our understanding at this point of time, right? Let me tell you, boss, the memory overview that I have drawn for you, right? Every grid in my memory is 1 byte long. Every grid has the space of 1 byte. So what do I mean when I say every grid is 1 byte long? That means I can store 8 bits of information inside my one particular cell. 1 byte means 8 bits. Okay, I can store 8 bits. Okay, so let's say if I want to store a number, I want to store 10. Okay, and I know that the 8 bit representation for 10 is this. Let's say this is 10, right? So I can basically reserve 1 byte of space in my memory. I can reserve 8 bits in my memory, and I can store 10 here. Okay, now let's say if I wanted to store a data which required 2 bytes. Okay, what I do, I will reserve space in memory for 2 bytes of information, and then I will store all the 2 bytes of information in these two particular cells, right? So, you need to know how much is the size that you want to store, right? And on the basis of that, you will be reserving space in your memory, right? Now, think of it like this, guys. Okay, I'll come to this later, but just let me come back once. So open up the chat. Yeah. So is this making sense, guys? What is a bit? What is a byte? I think it's new for most people, right? But do you understand what a bit is? What is a byte, right? And what is the storage unit? And now, so you have to understand that every cell has a particular storage capacity, right? It can store either 10 bits, it can store either 15 bits, it can store 8 bits, right? So I am telling a bit is nothing but a binary digit, right? So ऐसा सोचो, the space that you need to store one digit, either a 0 or a 1, right? The space that you need to store either a 0 or a 1, that is known as 1 bit. Okay, and 8 bits together, I call that, boss, 8 bits is one particular byte, 1 byte. So I am telling you, assume that every cell in your memory is 1 byte long. So you can store 8 bits of information. Again, you can understand it in different ways, right? You can even divide your cells further and tell me that, boss, every cell can store only 1 bit. That depends on the internal architecture, right? But yeah, what I wanted to make you guys understand it, you need to understand you need to understand what is the unit in which we are storing things, right? And you need to understand the idea of a bit and a byte. Okay, so if someone tells you, boss, I need 2 bytes of space, aapko pata hona chahiye what is 2 bytes of space. It is 16 bits, right? You are reserving 16 bits of space in your memory. Okay, so now if somebody tells you, boss, I have a 512 GB of hard disk, so I know that 512 GB, that means you can store 512 into 10 raised to whatever bytes. Okay, so if somebody tells you, boss, I have 1 MB of space, iska matlab kya hua? You can store 1 megabyte. Okay, 1 megabyte, right? That is how much? You can Google this up, right? But yeah, try to understand, right? 1 MB is 1024 bytes, if I am not wrong here, right? No, 10 to the power 6. 10 to the power 3 is KB. 10 to the power 3 is KB, right? So just give me 1 second. I think we all studied this. So 10 to the power 3 is like kilobyte, right? So when I say 1000 bytes or 1024 bytes, it's 1 KB. 10 to the power 6 is MB, megabyte. 10 to the power 9 is GB, gigabytes, right? But we don't want this, okay? Not needed, right? So if the fundamental idea, okay, I think I forgot to pause up the chats. Just give me 1 second. Otherwise it will spill over. But break, okay. Guys, I think the break won't be possible. We just have 20 minutes more of class. So I think it would be good if you focus for 20 minutes, right? And we'll be anyways rounding off, right? Okay. Okay, cool. Right. So far so good, right? We are clear with the memory architecture and how does the memory look like. Okay, that's fine, right? Now you will tell, boss, now let's do some programming, let's do some coding, right? Let's do some coding. Okay, so I'll say let's move on, and then I'll again come and tell some important things to you, right? So for now, I think we are good enough to do one question. Wait. Okay, so this is the portal, and let's go to start solving. Okay, so we'll look at the question, welcome to Java, and through this we will be learning some things, right? In the next 20 minutes, I want to make sure that everyone is clear with the fundamentals of the question. And then again, from tomorrow, maybe I'll discuss variables, data types, inputs, outputs, and all these things, right? So now after all these theoretical knowledge, right? What is high level language? What is compiler? What is this? What is that? What is memory? What is what not, right? We have discussed all these things, right? Now let's come down to some actual action and, let's write some code, right? So the things that you see on the screen, right? These are code that is written in Java language. Everything is Java. So definitely you can see, right? This is not plain simple English. In English, what is public, static, void, main, string, args? I don't know. This is not plain English, right? And definitely you shouldn't be writing plain English. You shouldn't be writing, hey, computer, add two numbers. No, you shouldn't be writing stuff like this, right? Because it won't be understandable by the computer. Okay. So this is the interface. Okay. Here we will be writing our code. Okay. And for today's class, what do we want to focus in? You will see that any Java program that you get, any Java program that you have to write, there will be this main. Let's forget what is this main, right? There will be public, static, void, main, bracket में string args, and then you will have two curly braces. And what I will tell, boss, forget what is written in line number 1, line number 2, line number 3. Forget what is public class main. Forget to, पता ही नहीं है तो भूलोगे कैसे, right? Just ignore what is public class main. Ignore what is public static void main throws java dot lang dot exception. Ignore everything. I am telling whatever instructions you have to give to your computer, you will be writing within these two curly braces of your main. Okay. So इधर में लिखा हुआ है ना your code here. So whatever instructions you have to give to your computer, you will be writing your instructions here. Okay. Whatever code I have to write, I will be writing in these two curly, within these two curly braces of my main. Okay. Now let's read this question and we'll try to learn a couple of things from this question. So welcome to the world of Java. In this challenge, you will learn how to print hello world to the standard output. Okay. So one of the questions that we always start our programming journey with is hello world program, right? It's like any day a standard. आप कोई भी language सीखो, you go and understand any language. The first question that we do is hello world, right? It gives you an idea whether everything is working fine or not. So what I want to do, I just want to print to the screen. Okay, I want to print to the screen hello world. Okay. So what is this written? Complete the code by copying the two lines of code below and pasting them inside the body of your main method. So I'll not, use my brains very much. I'll just copy these lines, right? मुझे नहीं पता क्या करते हैं, ठीक है? Then we'll try to analyze this. The next 15 minutes will be this job only. Okay. So let's just do one thing. Okay. So I have written this line, right? System.out.println. And see guys, when I told you will be writing an HLL, looking at this code, do you get some idea of what it might be doing? System.out.println. I don't know what is ln, what is not, but I am getting some idea, right? I will be printing something. What will I be printing? I will be printing hello world. And this is what I actually meant by a high level language. Looking at the high level language, you can understand what you want the computer to do. Okay. So I have written these two instructions, system.out.println hello world, system.out.println hello Java. And you understand that every line, every instruction that I am writing is ending with a semicolon. So this is the first rule of Java, that all the statements, every instruction will end with a semicolon. Very important, right? You cannot make it ambiguous. I cannot skip the semicolon here. If I skip the semicolon here, you know what will happen? When my compiler tries to compile the code, it will tell me, boss, you know what? You are writing in Java, which is a high level language, right? So Java has its own rules and its own syntaxes. What is syntax? Syntax is basically the rule that you have to follow while you code. Okay. So there is a proper syntax for Java. Okay. Ki boss, every line should end with a semicolon. Every statement should end with a semicolon. First and foremost rule of Java. Okay. Now, what does this actually mean? ऐसा पहले run करते हैं, right? First, let's look at the output and then see. Let's run the code. Okay. So why don't I see? Okay. So it's printing, right? Hello world, hello Java. So the code is running fine, and somehow my computer is able to receive the instruction and it is printing hello world and hello Java fine in two separate lines, right? Hello world, and in the next line hello Java is printed. Okay. So if I submit the code, this assignment will be fine, and this is done, as simple as that. But the basic idea of this assignment is to make you guys understand the meaning of these statements. Okay. So what does system.out.println actually mean? Okay. So in very simple terms, if I want to make you guys understand, right? Think of it like this. Boss, there is an output associated with your system, right? Inside your system, there is an output. What is the output of my system? The output of my system is the screen. Okay, my monitor, my screen is my output. So मैं बोल रहा हूँ, boss, whatever is the output of your system, inside the output of the system, can you please print? What do I need to print? Within brackets, I specify what I need to print. Okay, and whatever I want to print, I am putting it within double quotes. Okay, look at this very carefully. Whatever I want to print, I am putting it inside double quotes, and as it is, that thing is getting printed. So let's say if I blindly write another line here, system.out.println. What do I mean to say? Boss, whatever is the output of the system, can you please println? Can you please print there? What do I need to print? Within quotes, I say that you have been a nice audience. Okay, you have been a nice audience. I want to write this. Okay, and let's say I'm giving you anything, right? Let's say I'm telling you 5 plus 5. Okay, anything. Okay. So whatever I want to write, I just specify within double quotes, right? And at the end, let's try to run it. Complains. The compiler complains to me that, boss, you are writing in high level language. Why are you making it more ambiguous? There are certain rules and instructions that you need to follow. And what is that rule? That rule is every statement should end with a semicolon. So ye bol raha hai, boss, in line number 12, see how to understand the error. In this file main.java, at line number 12, there is an error. Semicolon was expected. So you go and look at line number 12, that, boss, you have missed a semicolon. So if I put a semicolon here, okay, and now if I run it, what will happen? In the third line, you will see you have been a nice audience. 5 plus 5 is printed. So what I want you guys to understand, whatever things you specify within this bracket, okay, you put parentheses here, and then within double quotes, you write what you want to print. And whatever you write within these quotes now, that will be printed as it is to the screen. 5 plus 5 is not printed as 10, right? Whatever you write within the double quotes, that will be printed as it is to the screen. Okay. So I will tell you later that whatever you are writing in the double quotes now, that is basically a string. We will deal with this later. Okay. But yeah, I think you understand the meaning of system.out.println. But what does println actually mean, right? See, there are two constructs that we want to understand, right? I'll tell you the difference. Okay. So let's say if I had written here system.out.print, you have been let's say nice audience, right? Again the same thing. Okay, so let's now try to run, and then I'll tell you the difference between system.out.print and system.out.println. Okay, so you won't be able to understand. Let's try to do it like this, then you'll understand. So I made the first line println and the second two are prints, right? Now let's run the code. Okay, interesting. So this time I'm not seeing the output in 3 separate lines, right? So now let us try to understand the difference between system.out.print and system.out.println. Okay. So what actually happens when you do a system.out.println, you are telling, boss, print this to the screen. And it's ln, this ln. This tells that, boss, after printing this, please go to the next line. Println means print and then go to new line. So see what happens if I want you guys to understand, how can I? Okay, let's go to here. I'll tell you, and then you will be able to understand. So what was my first line? My first line was SOP. I am using SOP as the short form for system.out.println. Okay. So let's say my first line was hello world. And then I was system.out.print. I'm just writing short forms here. Okay. Let's say what I've written. Let's say my name. Okay. And let's say after this I've written so print system.out.print, you have been a nice audience. Okay, you have been a nice audience. Okay, so how do I understand, right? So the first line that is executed, we know that it is sequential flow of execution. So the first line that will run is SOP hello world, system.out.println hello world. So think of it, when the program runs now, the cursor is at the first line of output. My cursor is here. So it will print hello world. So hello world will be printed in the first line. And after hello world is printed, because you have a system.out.println, after printing hello world, my cursor will move to the next line. So I come to a new line. Okay. This println will force the cursor to come to the new line. Now what I will do? The next statement that I execute is system.out.print my name. So my name will be printed. Okay. And because I have used a print statement and not a println, my cursor will stay on the same line. It will not move to the next line. Okay. Next, I go to line number 3 and I execute this statement. It is again system.out.print you have been a nice audience. So because my output cursor is here only, it has not gone to the next line. When I print this, this is also printed in the same line without any new line gap. Okay. So if you look at the output now, where has been the output? Kahan gaya bhai? Here. So if you look at the output, the first line was system.out.println. So I printed hello world in the first line and my cursor moved to the next line. Then I printed hello Java. So hello Java was printed and my cursor was standing here. Okay. It didn't move to the next line. Then I again had a system.out.print you have been a nice audience, or whatever my wrong spelling was there. So again, my cursor was here only. So it printed you have been a nice audience in this same line. And now my cursor is at the end of this E. Okay. So if I again write a system.out.print, I will see the contents printed in this line only. So what is the essential difference between a print and a println? A println, after printing, makes the cursor go to the new line or the next line, and system.out.print makes sure that the cursor stays at the same line only. It doesn't move. So see, after hello Java was printed now, the cursor did not move an inch. So when I printed you have been a nice audience, it just followed after without even a space. एक स्पेस भी नहीं आया. After hello Java, my cursor was here and it started printing you have been a nice audience from here. So if I want to introduce a space, what can I do? I can write a space here. Okay, hello Java space. So this will be the first string, and then I will print you have been a nice audience in the same line. Okay, so this time you will see that there is a gap between hello Java and you have been a nice audience. See, a space has been introduced. Okay, so acha. So I told you guys that whatever you put inside quotes, you will find it as it is, right? So let's say I do aisa kuch system.out.println. Okay. So let's say, acha, you have been a nice audience. Can anybody tell me where is my cursor? My cursor is here. Everyone agrees? After E, my cursor is standing. Let's say I want to get the cursor to the next line, right? So I can write here a statement like system.out.println. What? Nothing. I don't want to print anything. So what will happen? The cursor will come to the next line. So automatically now my cursor is in the third line. And what do I want to print here? Let's say I want to print 2 plus 2. Okay. So if I don't put quotes, now, you will see that addition will happen. Let's try to run and see. See 4. Okay. So basically inside your print, if you don't put quotes and if you put numbers, right, you can perform addition, you can perform subtraction, you can perform multiplication, you can perform division. Okay. So you can try to use your basic mathematical operators. What are the basic mathematical operators? Plus operator, right? It adds 2 numbers. Then you have the minus operator, right? So you can do a system.out.println, let's say 5 minus 2. It will give the output as 3. Then I'm just writing the operators here, right? So you have the plus operator, then you have the minus, which is the simple subtraction. Then you have division. And see, division has a very unique characteristics in computer, right? So whenever you divide now, in computer, we always do a floor division. What do I mean when I say floor division? So think of it like this. Let's say I am dividing 10 by 8. मैं ऐसा divide कर रहा हूँ, right? So let's say I have 10 and I am dividing it by 8. So you will have a quotient, okay, and you will have a remainder. So when I say 10 by 8, okay, you will always get the quotient. Okay. So 15 by 8 is not 1 point something. It is simply 1. Okay. Similarly, if you do 7 divided by 8, it is not 0 point something. It is simply 0. So when you do a division between two numbers now, it is basically a floor division. You get whatever will be there in the quotient. Okay. So we understood the plus operator, minus, multiplication, okay, which is the star operator, and then you have division. Division is this. Okay. One more operator is, boss, how do I get the remainder? Okay. When I divide 10 by 8, if I have to get the quotient, I know I can do a 10 by 8. What if I want to get the remainder? So you have another operator known as the modulo operator, this percentage, right? Percentage is known as the modulo operator. So if you do a 10% 8, you will get the result as 2. So what does the modulo operator do? Ki boss, when you divide 10 by 8, what is the remainder that you are getting? So 10 modulo 8 is, when I divide 10 by 8, the remainder that I get is 2. So the modulo operator is also known as the remainder operator. This will give you the remainder. Okay. So we talked about the basic mathematical operators, which are plus, minus, into, divide, divide into, and my modulo operator. And you can use these operators inside your print statement as of now, and you can perform, addition, subtraction, multiplication, division, or modulo of two numbers, right? Okay. Let's come here and let's go back to our chat. Yes, guys. So how many of you have understood system.out.print, system.out.println? If you put quotes inside the print, whatever is getting, that will get printed. Okay. So if I write a statement like this, right? So yeah, that is what we will be trying to do, right? Extreme. Now see, if I put here something like this, can you tell me what will be printed? Can anybody tell me what will be printed? System.out.print, within quotes, I am writing 2 plus 2. What will be printed? 2 plus 2 will be printed as it is, right? Because if you put in, quotes, then you are not performing any operations, right? You are printing whatever is there as it is without even thinking, right? So the fundamental takeaways from today's class would be, you should now be aware of the difference between a println versus a print. Okay. If somebody gives you different statements, system.out.println, system.out.print, and asks you to guess the output, you should be able to tell how these are working. Okay. And within these parentheses, if you put quotes and write anything, that is printed to the screen as it is. If you want to do operations, we don't put quotes, right? If you want to do 2 plus 2, you can do a 2 minus 3, 2 plus 5, whatever you want to do, right? So you can explore all these operators, plus, minus, into, divide, modulo operator. Okay, I'll also share links up for reading for you guys, right? So this is the basic idea for today's session, right? So are we all clear with what stuff we have discussed? 1 KB is 1024 bytes. Line 13. Line 13, what is line 13? Let's see. देख लेते भाई क्या है line 13, आ जाओ. Line 13 is nothing. Line 13 is system.out.println. It will just move the cursor to the new line. Okay. It will just make the cursor come to the next line. That's it. Okay. I could have avoided this statement, right? I could have avoided this statement if I wrote a println here, which would automatically print you have been a nice audience and take it to the next line, right? But because I used a print here and I wanted to take the cursor to the next line, I wrote a system.out.println in the next line, which will just take the cursor to the next line, right? Don't worry, what is this, right? Comments we will talk about tomorrow. Okay. So is everyone clear, guys? Let me take a feedback. Was the pace fine? Especially the people who are from a full non-tech background. So yeah, on the first day I told I want to, yeah, Aditya, don't worry. We will be going a little bit quicker. Basically, the first few lectures I intentionally go slow because I think lots of people, they need to catch up with what is being done, right? So I think सही है एक बार थोड़ा slow पढ़ाने से ही सही रहता है feel. Import Java, everything will do. Boss, at the end of module 1, you will understand everything. What is import, what is comment, what is what are loops, what are conditional, everything. Don't worry. Yeah, we'll first understand Java. First, we'll understand the fundamentals of Java and then only. Okay. So what is your homework, guys? What do I expect you to do? Okay. So I think most of you will be able to do it. एक मिनट रुकना यार. So now if you come to the module, right? If you come to the module, you will see that there are 3 questions. One I have already solved. Okay. Now your homework is you will be solving these 2 questions on your own. And in tomorrow's doubt session, so doubt classes will start from tomorrow. So from tomorrow, these 2 questions they will first discuss in the doubt session. Okay. And then they will continue from there. So your task is today only, everyone has to make sure that hello world assignment. See, it is no force from my end, right? Aaj karo, kal karo, kabhi karo, it's your wish at the end of the day. But I would suggest when your learning is, fresh, right? You can easily sit down and this will not take more than 20 minutes for sure, even for the beginners, right? So you can try these two questions, and what I will do is after the class, right, I will share. No, today there is no doubt class because we haven't covered anything as this, right? Full Java will be taught, right? Okay, so what I'm telling is I'll be sharing the notes, right? I just let you know where I will be sharing the notes. And when I say notes, you will get access to this PPT, right? So I hope that will solve your purpose, right? I'll share this PPT in PDF format so you can have a look at what all content we have covered. You have access to the recording, so you can review the recordings whenever you want and you get stuck anywhere. And I personally feel that today's class is basic, the first 3-4 classes, so no issues. Module 1, any module is approximately 25 days. Okay, score is 0. Don't worry about the score, worry about the learning at this point. As far as your learning is fine, I don't care if you are getting a 0 or a 50 there. Yeah, I'll share the complete syllabus. I can share with you guys. Okay, so cool guys, I think I'll stop the recording. Can I stop? No, we can't. Okay, so any other queries, any other concerns? No? Okay. Cool, guys. So yeah, anyways, yeah, what I was telling is generally we have 5 classes a week, right? So, but generally because module 1 starts off a little bit slowly, it's all dependent on you because we promise that it's from Monday to Friday only. But I think most of the students only agree that you can take on Saturdays as well, so that we are on track. Okay. So generally for my previous modules, I basically took classes for Saturday and Sunday also sometimes. Okay, for problem solving or for revising whatever we had done. So let's see. So we can see as how it actually goes. Okay. So abhi tak ke liye to sahi hai. Let's see. Okay. Cool guys. So yeah, class is over. You can drop off. And yep. So hopefully you enjoyed the class, and yeah, just revise it once, right? Compiler and interpreter. So compiler is more that it is compiling, it is converting my source code, and compilation happens before runtime. And interpreter is basically when you run the code now, then it is interpreted during runtime. Okay. I'll share the PPT on Discord also. Okay. So you can access it. Okay. Cool guys, chalo, good night. Let's meet you guys tomorrow, and hopefully bore नहीं किया तुम लोग को, and chalo, cool. थोड़ा explore करना, divide, modulo, all these things, right? Explore once on your own so that you also get decent idea of what is happening. Okay. My Discord ID is Adarsh112, AADARSH112. Okay. Cool guys, 800 every day. If people are responsive and you guys are finding it, see, generally we see that the trend is, with every passing day the strength drops a little bit. Sometimes some people they lag behind, so they go to the like recordings and all. But yeah, I've seen generally the strength is maintained decent enough. Okay, chalo, cool guys. Yep, let's meet tomorrow. Good night. Chalo, bye bye. Yeah, Jyoti, don't worry. So if you are finding it difficult to ask doubts, right? So again, in your doubt sessions, I think the fundamental objective has been there for this thing only, that take the assignments and then ask any doubts that you have, right? There you will have much lower audience, right? I think it will be around 100, and 100 may be how many of you turn up, that is dependent, right? So, yep. Chalo, cool guys. So let's meet tomorrow and we'll see. No more class from today. No doubt session. Doubt session start from tomorrow. Okay. So you study today. Now you solve problems a little bit. Whatever 2 questions have been given and whatever concepts you have done, from tomorrow your doubt classes will start. Okay. Chalo guys. Bye bye.